Good morning. My name is Dan Judd. I work for MSA. MSA is a manufacturer of safety equipment. 4 product groups. Our hard hats, which all you guys are wearing out here with the V on it. That's our hard hat, the V guards. Confined space monitors, portable gas detection, infix gas detection, respiratory protection, and then what we're going to talk about today is fall protection. All right, so we're only going to do about 20 minutes here. I'm going to cover the basics. If you guys like what you see, please invite me back for the stand down and we'll do the full hour presentation. But just so you know, before you leave, everybody's a winner with MSA. So I have safety glasses on the side of the truck for you, as well as some other swag. If it will work, you all use full bibs, so the other swag might not work. They're sunshades for the summertime. No good this year or this time of year. But if you answer some questions correctly, I might even have a prize for you at the end. And then I also have hard hat stickers for all of you if you allow hard hat stickers. So let's get started. So when I talk about fall protection, I always like to start with the basics. And we're going to get into the ABCs, but I want to start with 2 principles that you need to think about. And I'm not going to get into how these principles came about, but start with 2 principles that you should always think about when you're working at heights. And I call them the principles of fall protection. The first principle, you want to think about, why am I wearing this equipment on this job site? Well, that first principle is the reason you're wearing it is so you don't hit the ground. We can't prevent all falls, but we want to make sure we're not going to hit the ground if we do fall. Make sense? Yeah, so first principle, whenever you're up at heights, think about, how can I work to not hit the ground? So don't hit the ground. And the second principle is I want to minimize the force on my body. And so as a manufacturer, we do a lot of that for you with the equipment, but there's a reason why you want to minimize that force. So if you fall using a lanyard like this without an energy absorber on it, you will generate upwards of 4,000 pounds of force. 220-pound person will generate around 3,600 pounds of force when they fall 6 feet. Yeah, that's enough to kill you. So we need to minimize the force on our body. So as a manufacturer, we try to get that force down to less than 900 pounds. But there's some stuff that you could do to minimize that force also. So the first thing is if I want to minimize the force on my body, I need to minimize my weight. Now I know you're all looking at me going, yeah, very funny. Look at this guy telling me to minimize my weight. Look in the mirror, buddy. That's all right. I'm not meaning you got to lose weight. Hey, I'm from Wisconsin. I like beer and cheese as much as the next guy. What I'm telling you is to minimize our weight. If we're 220 pounds and we had a 70-pound tool belt, what's our weight now? 290 pounds, right? So to minimize our weight working at heights, let's only take the tools we need for that job. Don't wear that whole tool belt if you don't need it. All right? Because it's going to be a lot less force on your body if you don't have all that extra weight on you. The other way we can minimize the force on our body is minimize the distance we fall. So here's a 6-foot lanyard. When I fall, I'm going to fall 6 feet before my energy absorber deploys if this is attached parallel to my D-ring, right? So if I'm attached parallel to my D-ring and I fall, I'm going to fall 6 feet, which could generate a lot of force. But if I raise my anchor point, do I fall 6 feet anymore? No. No, I fall a shorter distance. So if I want to minimize my force, I minimize my weight and I minimize the distance I fall. So those are 2 things we always want to think about when we're working at heights. 1, how do I not hit the ground? 2, if I do fall, how do I minimize the force on my body? All right? So I don't have time. I want to get you out of the cold. I'm not going to go over the hierarchy of fall protection as it's written in the standard, but we're going to move right into the ABCs, and that's for the personal protective equipment we wear. All right? All right, so you all know what PPE is, personal protective equipment. You have your hard hats, your safety glasses, your high-vis clothing, your steel-toe boots. While all the equipment behind me is also personal protective equipment. But we call it, in fall protection, we call it something different. Some people refer to it as a personal fall protection system. Some people refer to it as a personal fall arrest system. The key word in all of that is system. All right? It all works as a system made up of 3 points, and we call it the ABCs. ABCs of fall protection. So A is our anchorage. It's our anchor point and our anchorage connector. So, I know all of you have been through some sort of fall protection training. What does an uncertified anchor point have to be rated for? 5,000 pounds. How do we determine that?
By the rating on the anchors and what it's anchored to.
Yeah. So that's the anchorage connector unless you have certified beams and stuff like that. So uncertified, when we're working and we're looking for something to tie off to, the anchor point, that's what we actually attach to. I always suggest look for something structural. If it's going to hold that structure up, it's probably safe to use once it's set, like large concrete columns, your large I-beams after the steel erectors go through. But to imagine what to tie off to, imagine this. Imagine a full-size vehicle like my truck hanging from it. And if you can visualize that, then you could use it as a tie-off point. All right? That's uncertified. Certified, your structural engineers could do some non-destructive testing and actually stamp certified anchor points like your I-beams and stuff like that if you have them on site. So that's the anchor point. We're also going to do your anchorage connectors. So again, this one's out of service, but I like to use it as an example. This is called an anchorage strap, and how these work is this, you just throw this around your I-beam or your concrete column, and you pass the small D-ring through that large D-ring, and this one is designed to be choked off, and you tie off right there. So there's 5 areas we want to look at on the harness. First area is going to be our metal parts. So we're going to look at our D-ring and make sure there's no excessive rust or corrosion. Make sure it's not bent, cracked, or broken, all right? But a little bit of rust or corrosion, like you see a spot starting, you're probably going to make it through the day. But if it's pitted and you can scrape metal off it, you probably want to take it out of service, all right? Then we're going to go down and we're going to look at our buckles to make sure they function properly. So this is actually a quick connect buckle. So you see those 2 silver levers on this buckle? Those are locking levers. So anything quick connecting has to have 2 locking levers on it and fall protection. So how do I inspect it? I just push in one of them, try and open that buckle. Then I push in the other one, try and open it. Then I just make sure it functions properly. Again, make sure it's not bent, cracked, or broken, no excessive rust or corrosion. If you have a mating or pass-through buckle, again, make sure it's not bent, cracked, or broken, no excessive rust or corrosion. Then I'm going to check my adjusters. Again, no excessive rust or corrosion, not bent, cracked, or broken, but then I'm going to make sure that I can just pull the webbing in and out of that a little bit, all right? And then the leg straps, this has the same type of connections. But you might have a harness with these type of leg straps, right? This is called a tongue buckle leg strap. So what do I inspect on here? I make sure all the grommets are there. None of them are missing. None of them are crushed. No excessive rust or corrosion. And then make sure no one added their own grommet holes in the webbing. Then I also look at the buckle. Make sure there's no excessive rust or corrosion. Make sure it's not broken. So that's the metal parts. Then we're going to check the plastic parts. And the plastic you're going to look for is your D-ring shim. We're going to make sure it's there. It's not missing, it's not excessively worn, and it's not broken. This D-ring shim is important because it holds that D-ring in place if you fall, so you don't have an awkward fall, all right? Then we're going to check the webbing, and how we look at the webbing is we run our fingers across it while we visually look at it. And what we're looking for is excessive grease and dirt, excessive paint, excessive weld spatter, chemical exposure, excessive UV exposure, cuts, rips, and tears. So let's go over that. Again, I said excessive quite a bit. So what I'm saying, if you have a lot of grease and dirt on your harness, take some mild detergent, wash it, hang it to air dry, all right? If you have a couple specks of paint, you're probably going to get through the day, but if it's coated in paint, because you're a painter, take it out of service. Get a new harness. Same with the welders. If you have a couple weld BBs on your harness, probably going to make it through the day. But if you have spatter all over your harness and burn holes all over that harness, probably want to take it out of service. But this is your discretion. All right? And then that UV exposure, excessive UV exposure. How do we know something has too much UV exposure? It's faded, right? So this is actually a red harness, if you can see that. If it's pink when I pull it out of my job box, I want to take it out of service. All right? And then chemicals. Chemicals mainly do two things to the harness. They'll either harden the webbing, where you'll have this stiff area that's no longer flexible or pliable, or they'll bleach the webbing, meaning you'll have white spots on it. You see either of those, take it out of service, all right? And then the last one that I can't stress enough, because I don't care how small it is. I don't care if it's just a minor nick. Any cuts, any nicks, any deep abrasions, out of service. Risking your life over a minor cut isn't worth it on your equipment. When you nick this webbing, you greatly reduce the strength by over 50%. And if you fall and there's enough pressure on it, it'll rip right open on you. All right? So don't mess around with cuts. I like to use the example, because I'm from Wisconsin. Think of a shredded cheese package, right? The shredded cheese package at the top, it's perforated so you could open it. It has that little notch so you can open it nice and easy. Well, that's the same thing that happens when you nick your harness. All right, make it open nice and easy on you. So, that's the webbing. Then we're going to look at the stitching. So you're going to look on your harnesses for any type of pattern stitches. Those are your load-bearing stitches. So here I got a bunch of box pattern stitches right here. Those are what I want to inspect. And how do I inspect it for before use? I'm just going to try and pull it apart at the seams with my hands. All right? I'm not going to go through and try and tell you to look for pulled stitches everywhere. Just try and pull it apart. If you can pull it apart, you have pulled stitches in there and need to take it out of service. All right? And then the last area we're going to look at on the harness is the labels. These are required to be on the equipment. You must be able to read them, and they must be there. They have to be present. Unless the company identifies that equipment some other way and has an owner's manual for you to read. But for rule of thumb, we want them on the equipment. They must be legible and none of them missing. So why are these labels so important? Because they tell us everything we need to know about that harness. All the warnings are in there. The max capacity for the workers on there. The date of when it was made is on there. The manufacturer number, the serial number. A spot for the competent person to sign off on their inspection. A spot for you to write your name. All that is on the equipment. All right? So after I inspect it, I'm ready to put it on. Any questions on that?
I have one question for you.
Yes, sir.
That comes up quite often when inspecting these is born date or expiration of a harness.
Good.
Is there any standard? OSHA requires 5 years,
Yes.
10 years. We have something within our company, but I'm just curious what if you knew what
Yeah,
the absolute
yeah,
was.
yeah. So good question. So the question was, and I'm going to paraphrase it or summarize it. What is the service life of a harness? Is that correct?
Correct.
So let me ask you guys what you think. What is the service life of the equipment?
Generally, you kind of say 5 years.
5 years? And 5 years is kind of rule of thumb, but there is no set standard. So where do you think you would find that information? On the labels. So it is actually up to the manufacturer to decide if they're going to put an expiration date on the equipment or not. So at MSA, and we're not the only ones, but we say service life is based on inspection. not on age. Because we know some harnesses aren't going to make it 5 years because the guy's working them every day. And we know some guys only need their harness once or twice a year to inspect something or look at something. And if they take care of it, it might last them 10 years. So MSA says service life is solely based on inspection, not on age. But if your company has the policy, take out a service after 5 years from first date or first use date, that's fine. That's a good practice. All right. I'm not going to complain about it being a manufacturer because that means you're buying harnesses every 5 years. So, but it's up to the manufacturer. And some of them say on their tags, take out a service after 5 years. Some say after 3. One manufacturer even says after 2 years. But we don't say that. All right, so I inspected my harness. So I'm ready to put it on. And with all my winter stuff on, yeah, I'm looking like Tommy Boy here. All right, so I got my harness on, and I'll leave my gloves there for a minute to adjust it. I got my harness on. Am I ready to go to work? What's wrong? It's nice and loose, comfortable. I could work all day like this. Nice and loose. All right, so there's a reason why I do this exercise. My harness is too loose. I need to tighten it up. How many times, you just corrected me and you don't know me from anybody. How many times you walk across your job site and whether it's one of your employees or a subcontractor on site, you see people in loose fitting harnesses? Quite a bit, right? Are we trying to protect everybody, making sure we're going home safely? It doesn't take a lot. Just say, hey, buddy, tighten up your harness. If you don't, you're going to be in a lot of pain. And here's why you're going to be in a lot of pain. You got to think of how gravity works. So when you fall, that anchorage connector is holding your connecting device, your lanyard or your self-retracted lifeline, and that's what's stopping first. And that equipment is actually stopping the harness. And the harness is stopping you. So if you have loose leg straps and a loose fitting harness, where are those straps going to be when you're done falling? They're going to be in an area that's going to cause a lot of pain. I promise you, whether you're male or female, they're going to be in an area that causes a lot of pain. If you don't believe me, just Google loose fitting harness. The stories will come up. The horror stories will come up. So I need to tighten it up. So I like to attach my leg straps first before I tighten it up. Just tighten. And then I start with my shoulder straps. And these are pull down adjusters. Some harnesses have pull up adjusters. And this will bring my leg straps up to where they need to go. My keeper's interfering here, but that's all right. So that brought my leg straps where they need to go. Then my leg straps just out and over. Then my chest strap out and over. So even playing around with that one buckle, how long did it take me to tighten my harness correctly?
Not long.
Not long. So the key word is snug. Everything has to be snug on the equipment, all right? So my shoulder straps are snug enough when my leg straps are in the proper placement. My leg straps are snug enough when I take the palm of my hand, slide it between my pant leg and my leg strap, and I can't move it around. But if I can make a fist, move it all around, it's too loose, all right? And then my chest strap is snug enough when it's right across the chest and I physically can't pull my shoulder straps off my shoulders. All right? And we want it right across the chest. If it's too high and I fall, I could actually choke myself. If it's too low and I fall, believe it or not, your shoulder straps could come off and that means you could fall out of the harness. All right? So that's inspection. One thing I do want to show.
I'm sorry, I want to add something. I noticed you have something big in your pocket. When you're putting these harnesses on, take everything out of your front and back pocket so they can get a good fit. So your phone's not getting jammed into you.
Yeah, that's a good point. I usually do empty my pockets. Cold weather's playing with my mind out here. But that's very important because if you have a pen or keys are in there and you fall, that could jam right through your pockets, right into the skin, and And there are rare cases of it actually hitting arteries and people bleeding out because of keys or a pen or something like that. One thing I do want to show is that there is a new style, and your safety manager is going to give some of you guys a chance to try it out. But I just want to highlight this harness because it's very new to the market, and basically how it connects is it's a racing style connection. But we're going to tighten it the same way as what I just showed you, but there's some nice lightweight, nice padding on it. Suspension trauma steps are built right in, and we're going to talk about that in a little bit. But you guys are going to get a chance to wear this harness on the job site. Is that correct? So just if you're curious about it, tightens the same way. But we have this racing strap connection, or racing style connection, to avoid that chest strap. All right, any questions on harnesses? One last thing I want to point out is if you're going to write on the equipment, and I don't know what your policy is, but if you're going to write on the equipment, only use a Sharpie by Sanford non-toxic marker. It's the only one we've tested, as well as pretty much all the other manufacturers, all right? So you're going to write on it, must be Sharpie by Sanford brand. You might have a policy where you're only going to write on the label, where it allows you to, and not on the harness itself. That's fine too. That's why we do that. All right, so I covered A, anchorage. I covered B, body wear. Oh, we're wrapping up here. We're getting to the fun part, and that's our connecting devices. So that's our lanyards and our self-retracting lifelines. What's the first thing I do when I grab my lanyard? I inspect it. And I, just like everything else, I'm looking for the metal parts, the plastic parts, the webbing, the stitching, and the labels. But now I have snap hooks I need to worry about. So I look at my snap hook, and all snap hooks must be self-closing and self-locking, meaning I have this locking lever here that I got to press in to open the gate. So how do I inspect it? I make sure I can't open that gate without pushing in that locking lever. And then when I close it, when I release it, both the gate and the locking lever go to the start position. All right? So, couple things about lanyards. Can I take my lanyard tie back to itself because I forgot my anchorage strap and choke it off that way? No, I can't do it with this one. But look at these snap hooks. It's like more of a carabiner style. Can I take this lanyard, throw it around my I-beam, tie back to itself? Yes, I can. How do I know? Because I read the label. This is our tie-back lanyard. It's called an FP5K tie-back lanyard. So there is equipment that's allowed to tie back to itself. Now I have no preference. Whether you buy tie-back or non-tie-back, that's entirely up to the company. The only suggestion I make is if you use tie-back equipment, don't allow any other type of personal lanyard or personal fall limiter that's not tie-back on your job site. Because we don't want you guys using this equipment properly, and then you get somebody new out of the hall tomorrow that didn't go through fall protection training, grabs that yellow one, saw you tie back with this one, they tie back with that one, and they fall and blow out the gate. So if you're going to use tie back, I just recommend that's the only equipment on a job site. All right? This harness, or this lanyard, also has 2 legs on it. Not going to question your guys' intelligence. This is for 100% tie-off. Just go through that real quick. That means I'm connected over here. I need to get over there. I can walk over there, connect the other leg, come back, unhook, and then stay tied off all times. You can also do it with hooks like this. You think about you're at a job site with fixed ladders. You're going to climb the ladders. You're going to hook up on the rung, climb up to waist level, and that's your climbing system all the way up. All right, so whenever we use a lanyard, we got to think about fall clearance calculation. So we think about those principles of not hitting the ground. So in construction, we know we got to be tied off at 6 feet. All right? So whenever we use the lanyard, we want to use it correctly. If I'm tied off with a lanyard 6 feet off the ground, am I going to hit the ground? Yes. So I need to do a fall clearance calculation. So I'm going to take my free fall distance plus my deceleration distance plus the height of my body plus a safety factor. So free fall distance, that's the amount I fall before my shock absorber deploys. So if I'm tied off parallel to my D-ring and I fall, that first distance is going to be 6 foot with a 6-foot lanyard. Now I'm 6 feet from my anchor point to my D-ring. Then my shock absorber is going to pull out. And we have we have 4 feet of material to bring your force down to a manageable level. Our goal is less than 900 pounds. But now it can be 10 feet from the anchor point to our D-ring. Then you got to take into account the height of your body. So for me, that's what, like 7, 8 inches? Come on, my timing was perfect on that joke, guys. For the rest of you, we're going to say 6 feet. So now we're 16 feet from our anchor point to our toes. And then we're going to add a safety factor of 2 to 3 feet. So we say anywhere from 18 to 19 feet of clearance you need for a shock absorbing lanyard. I'm going to show you what that looks like. So I have Woody hooked up to a shock absorbing lanyard. And let's see what happens when he falls. So Woody is a 220-pound test torso. All right, so here's a fall with the shock absorbing lanyard. So at that height, you know, my toes might be dangling, but the rest of you would have broken legs, right? So there's got to be a better way. That better way is self-retracting lifelines. So the first thing I do when I grab my SRL is I inspect it. Everything's the same. But now I have cable I have to worry about on most of them. So I'm going to look for excessive rust and corrosion on the cable, broken strands, kinks in it, and I'm also going to look for bird caging, meaning that the cable got all bunched up and it's all loose. All right? I'm also going to do this to it. What did I just do? I locked it up, because I'm telling you right now, if it won't lock up when you do this, there's a good chance it's not going to lock up when you fall. All right? So, a few things about SRLs. I never want to take my normal SRL and walk out like this with it. Always want it anchored overhead or no more than 2 feet below the D-ring on the smaller ones. The reason is this is a 50-foot SRL. If I'm 20 feet off the ground and I walk out 50 feet and I fall, what's going to happen? I'm going to hit the ground. If I'm 100 feet up, I'm going to go for a ride and I fall, all right? So rule of thumb is you don't want to walk out any more than 6 feet like you could with a lanyard, or 15 degrees in any way with an SRL. Now we make these all the way up to 135 feet, and we make different styles. So we have a 50-foot, we have field repairable units, we have clear housing units with retraction dampeners, we have minis and single leg and twin leg that are only 6 feet and 10 feet long. We have them in all different styles. But any of those, you don't want to walk out any more than 6 feet. So you might be thinking to yourself, if you remember my name, you might be thinking, Dan, why do you make longer SRLs then if I could only walk out 6 feet? Well, the reason's behind you. It's for when your anchor point is that much higher than where you're working. All right? Now, there is times that you have to be on applications where you have to tie off at foot level. And if they go over or you fall, that line is hitting some sort of edge. We have leading edge equipment. So this big yellow one is a leading edge SRL, meaning it can be tied off overhead all the way to foot level. You're going to have an inline shock absorber up on your back. And when this hits an edge, it's not going to shear, and it's still going to absorb that fall. So that's a 30-footer. We also have this 20-footer with the roll cage that protects the structure that just rolls around with you. A leading edge device. And we also have minis in twin leg and single leg, both a cable and webbing. And these webbed ones that we have actually pass that sharp edge test. So it can be used for any leading edge application. Any questions?
Yeah, let's say you want to tie off up there. How do you tie off? Say your tie off point 25 foot above you.
Yeah.
How do you tie it off up there?
Yeah.
Without fall protection on, without being tied off.
Yeah. So I don't know, does your company practice first man up policies?
We generally don't, but that's good. One person is qualified, certified, go up an assessment point, and then they will make sure that you won't be off. So no person up doesn't have to be tied off if they're following some kind of
Otherwise, we do make, so like if you can't get up there with the lift to tie off, then come back down to where you're working. We do make what's called a remote connection device, which is a telescoping pole that you could get your strap around there and then connect your SRL off of it. So there is equipment out there like that too. All right, so fall protection standard says I have to be tied off at 6 feet or in fall protection at 6 feet. We know a lanyard won't work because I need 18 to 19 feet of clearance. Just want to show you what a fall with SRL looks like. So, what I want you to pay attention to is where that D-ring is before we fall and where Woody ends up after the fall, all right? How far did he fall? Maybe a foot? All right. Last thing I'm going to talk about. Any questions on connecting devices? I'm pushing right up against my time here. Last thing that's very important to me I'm going to talk about is rescue. You must have a rescue plan. OSHA requires it. And it says that that rescue must take place in prompt fashion, meaning it must take place promptly, must take place right now, immediately. ANSI says, but they actually have in their standard from the time a person falls to the time they should be on the ground rescued should be less than 15 minutes. To make you guys understand how quick promptly means, so we'll ask the gentleman in here, are any of you married in here? When your wife says she wants something done promptly, what's she mean? 6 months, you're a lucky man. That's like my wife, she means right now, yesterday, as quick as possible. All right? So, the reason is because that harness that you're wearing correctly is now hurting the body. It's called suspension trauma. The leg straps are cutting off the circulation. Blood is pooling at the feet. Cannot get back up to the heart. You'll eventually go unconscious. Your organs will eventually shut down. And there are cases of people that have died hanging in their harness waiting to be rescued. So it's important you have a rescue plan. So I'm not going to tell you what your company's rescue plan should be because it's different on each job site. But you guys should review that. What I am going to tell you, if you're the person that fell, there's some stuff you could do to help prevent suspension trauma. 1, bicycle kick. Keep lifting that pressure off your legs as long as you can, if you can. 2, between your leg straps, harnesses are required to have a seat strap. So this is designed to actually pull yourself in a sitting position if you could get in it, all right? Once you fall. And then 3, we have suspension trauma steps, and all manufacturers make them. This is ours. We can attach this anywhere on the harness, underneath the D-ring between the webbing. I can attach it on the hip, anywhere that's load bearing. And how it works is if I fall, I have this Velcro pouch at the bottom. I just release it, and I have an etreator system that I find a spot for my boot to go in with my knee bent, and I just lean back and kick out. Puts me at a standing position. Cheapest insurance policy any company could buy. Now you might have areas on your job site where rescue is problematic. This one's a little bit different because I don't know how much we want to lower people down for rescue. But if you're on flat ground and you have those areas where rescue is problematic, or you have lone workers, they have to have the capability of self-rescue. We have a device called a personal rescue device. And how this works is you wear it like your normal harness. You attach your SRL or your lanyard right here. You fall, it stops you. And once you're hanging there, you pull this red cord, and it will lower you to the ground at 3 to 4 feet per second. So what we have in here is 65 feet of Kermantle rope on a belay system. All right, any questions? 65 feet. But, all right, that is all I have for you. I know I went a couple minutes over. I hope you all stayed warm. Again, I have the safety glasses on the side for you. I have one prize winner because I want to get you out of here, so I didn't ask a lot of questions. But I want to thank, one, the construction channel for inviting me on site, the superintendent for allowing me on site, and safety for allowing me to do this presentation. I also have hard hat stickers for you. Again, my name's Dan Judd. I work for MSA. Thank you very much, guys.